This is PreCalc 11, Chapter 1.6. Recall if the absolute value of r is less than 1. Using limits, we find that Tn approaches 0 when n gets very large. So if we look at Sn equals to T1 times 1 minus r to the power of n, all divided by 1 minus r, this will become 0. And the whole term will become 1. Since r to the n is 0. So S infinity equals T1 over 1 minus r. That's only if the absolute value of r is less than 1. So this makes the sum of an infinite geometric sequence more interesting. For example, what is the sum of the infinite geometric sequence? 4, 4/3, 4/9, 4/27, and so on. S infinity equals 4 over 1 minus 1/3. This is 4 over 2/3, and that's 12 over 2, and that's just 6. Okay, we multiply by the reciprocal of the denominator. That's 3 over 2, so it's 3 times 4, which gives us 12. So you can see that this is a simpler problem. And again, we need to be able to solve a backwards problem. We're given the sum of the infinite series is 14 over 3. Term 1 is 7, find r. So S infinity equals T1 over 1 minus r. This gives us 14 over 3, we're substituting, equals 7 over 1 minus r. We have 1 minus r, and we multiply the other side by 3 over 14. So this is 7 times 3 over 14. Isolate the negative r, we move the 1 to the other side, so this is minus 1 minus r equals 21 over 14, and that's a minus 1. And we have minus r equals, this simplifies into 3 over 2 because the common factor is 7, minus 1, so that's 2 over 2, 3 minus 2 over 2. And we get minus r equals 1/2, so r equals negative 1/2. Another example. The infinite sum is equal to 18. The ratio is 2/3. Find T1. So S infinity equals T1 over 1 minus r. Substitute everything in. We have 18 equals T1 over 1 minus 2/3. This is 18 equals T1 over 1/3. And we multiply both sides by 1/3. So T1 equals 6. We're multiplying by 1/3 because we're dividing by 1/3 here, and the opposite of that is multiply. Finally, we're going to look at an example from the workbook 8a. Use an infinite geometric series to express this decimal as a fraction. So we have 0.497 repeat equals 4 over 10 plus 97 over 10 to the 3 plus 97 over 10 to the 5 plus 97 over 10 to the 7 plus ... So for this, we have T1 equal to 97 over 10 to the 3. And for each one, we're multiplying this term by 1 over 100. So r equals 1 over 100. So we have S infinity equals 97 over 1,000, all divided by 1 minus 1 over 100. And this gives us 97 over 1,000, and 1 minus 1/100th is 99 over 100. So we have to multiply by the reciprocal, which is 100 over 99. We cancel 100 from here and here, so we're left with 10. And this gives us 97 over 990. So over here we have 4 over 10 plus 97 over 990. And we'd like to use a common denominator. That would be 990. That means we need to multiply this numerator and denominator by 99. And then we get 493 over 990. And that completes this lesson.